Welcome to Math with Professor V. Here is your latest integral of the day. And I had a request from somebody. They wanted a problem that involved partial fractions, but you needed to long divide first. So I'm sorry I spoiled the solution technique already, but I just wanted you guys to know where this was heading. So we have indefinite integral of 2y to the fourth over y cubed minus y squared plus y minus 1 dy. So how do we know we need to do long division first? Because this rational function is top heavy. So you only can do partial fraction decomp when the degree of the denominator is higher than the degree of the numerator. So if the degree is equal or higher in the top, gotta long divide first. You want bottom heavy. My high school pre-calc teacher said you want a J-Lo rational expression. You want it bottom heavy, not top heavy, Dolly Parton. He really would say that. Anyways, burned in my brain. Here we go. Let's long divide. I'm going to take the denominator, y cubed minus y squared plus y minus 1, and divide it into 2y to the fourth. So just look at the leading terms. What do I multiply y cubed by to make it 2y to the fourth? I multiply it by 2y. And then the next step, what we do is we distribute that 2y to the divisor, and I list the result underneath. So we're going to have 2y to the fourth minus 2y cubed plus 2y squared minus 2y. And you know this mess is going to bother me, so I'm getting rid of it. Then in the next step, we subtract that new row from the row up above. Everything on the furthest left, that term should cancel out. And then the result is just going to switch all the signs. So this is positive 2y cubed minus 2y squared plus 2y now. And then I repeat the process. So I go, okay, y cubed divided into 2y cubed. I just get a 2 back, so plus 2. Then I distribute this 2 to everybody outside to the divisor, and I list the result underneath. So we're going to have 2y cubed minus 2y squared plus 2y minus 2. Then, yes, we subtract this row from the one above. And not only does the term furthest to the left cancel out, everybody cancels, except for this negative 2, which after I distribute this negative will become a positive 2. Whew, so that's my remainder. So I'm going to say plus, I have 2 divided by y cubed minus y squared plus y minus 1. Okay, so now I can rewrite this integral as integral 2y plus 2 plus 2 over y cubed minus y squared plus y minus 1 dy. Good? Okay, now it's time to find the partial fraction decomposition for that last term right there. Okay, and then 2y and 2, we can integrate those, no big deal. So partial fraction time, we have 2 over y cubed minus y squared plus y minus 1. It's 4 terms. Typically when there's 4 terms, we factor by grouping. So I'm going to take out the GCF for the first 2 terms, greatest common factor. I can take out a y squared. And we have y minus 1 plus just 1 times y minus 1. So you see how y minus 1 factors out? Oh, good. So we've got y minus 1, and then the other factor is just going to be y squared plus 1. Ooh, how exciting. So y minus 1, that's a linear factor, so we just have a over y minus 1. And then y squared plus 1 doesn't factor any further. Irreducible quadratic. So I need by plus c in the top. Yes. Now, multiply everybody by the LCD, which is y minus 1, y squared plus 1. And our goal is to solve for a, b, and c. So we're going to have 2 equals a times y squared plus 1 plus by plus c times y minus 1. So 2 equals ay squared plus a plus by squared minus by plus cy minus c. Okay, To solve for a, b, and c, I'm going to equate the coefficients of like terms from both sides of the equation. So starting with y squared, I don't see any y squareds on the left. And then I have a y squared and b y squared on the right. So 0 must equal a plus b. Y to the first, none on the left, negative b plus c on the right. And then constant, which is y to the 0, 2 equals a minus c. Oh, this is not nice. No, actually it's fine. So from the second equation, I can see b is equal to c. It is. And if I substitute that into the third equation here, b is equal to c. 2 equals a minus b, since b is c. And the first equation is 0 equals a plus b. If I just add these two together, b cancels out and I get 2 equals 2a. Yes, so a is 1. And then if a is 1, and I know a plus b is 0, then b is negative 1. And then remember, b equals c, so c is negative 1. Boom. That was fun. Okay, so now I can put everything all together. I'm going to put a positive 1 here, a negative 1, and negative 1 here, and I'm going to put it all in the integral with the 2y and the 2 in the front. Are you ready? All together now. All together. We have integral 2y plus 2 plus 1 over y minus 1 plus negative y minus 1 over y squared plus 1, close her up, dy. Okay, anytime you have that irreducible quadratic and there's two terms in the numerator, you got to split them up to integrate. So we're going to go 2y plus 2, we're good with those, plus 1 over y minus 1 minus y over y squared plus 1. And then this should be minus 1 over y squared plus 1 dy. So now we can just go term by term and integrate. Depending on where you are in your math career, your calculus career, you may need to do this one off to the side because it's going to involve a u sub. For my more advanced viewers, you can probably do the whole u sub in your head. So if you need to do it aside, you know, keep the negative, don't. I say let's not. You just have y over y squared plus 1 dy, and you would let u be y squared plus 1 because it's 1 degree higher than the numerator. Then du is 2y dy. So 1/2 du is y dy. And then we're going to end up with 1/2 integral du over u, which is 1/2 ln absolute value of u. I'm going to say plus k because I want to save c for the very end. And then this is 1/2 natural log. I don't need to keep absolute value because u was y squared plus 1. That's not going to be negative, plus k. So I just want to point something out. As you practice more integrals, you'll do this part in your head because you notice, oh, the degree of the denominator is 1 higher than the numerator. And you basically do this process in your head and you go, oh, I'm just going to pick up a 1/2, and you have ln of the denominator. And you can just jump straight to the end. Okay, so that's what I'm going to do here. If that feels way too much, then don't do it yet. It will happen naturally after you've practiced enough integration problems that you'll do it in your head without much effort. So this is going to be antiderivative of 2y, y squared, plus, then we have 2y, plus 1 over y minus 1, that's going to be ln, absolute value, y minus 1, minus, this is 1/2 ln, I can just switch to parentheses, y squared plus 1, minus, ooh, do you know who this antiderivative this is? Yes, our good friend, tan inverse of y, and then grand finale plus c. Okay, so that concludes your integral of the day. I hope you enjoyed it. I forget who asked for long division and partial fractions. I have a few others if you go through the playlist, probably very early on, more than a year old, where I've done some, but if this is like a recurring issue that we need more practice with, I'm more than happy to do them. So give the video a thumbs up, subscribe if you haven't already. Let me know how you enjoyed it. Can you guys do the U sub in your head, or do you need me to write it out? I guess that's something I'm curious. Where are my viewers at? I don't want to bore anyone, but I don't want to skip too many steps. That's not the point here. The point is to help you guys learn, improve your skills, and also give you fun problems to practice. If you need help with any other calculus related topics, then check out my playlists on my YouTube channel. I have Calc 1, 2, 3, linear algebra, differential equations for members, pre-calc, stats, all sorts of stuff. And also please follow me on Instagram, TikTok, Math with Professor V. I love you all. I'll be back sooner than later. Bye.